Hello learners. So today we are starting about functions in C++. It is a very important topic. Functions are really helpful for the programmer to divide the program into small units. By dividing the units, programmers are easily able to solve the problems. These small units are specific to the task. So that's why we are approaching here modular programming. This approach is called modular programming to prepare modules. Small units of a software is called modules. Each module having a specific feature, each module having a specific characteristics. According to the characteristics and features, we divide our software into smaller units. Each smaller unit will be implementing separately to each other. After implementing each unit separately, integrate all together and make a featured software in one program. So now we are going to study according how to make modules, how to make functions. So outline of this lecture: functions, or you can say member functions, or modules, or methods, or procedure, or subroutines. These are the different name of functions in different programming languages. Types of function: we have two types of function: system defined functions and user defined functions. After that, for user defined functions, we have another two types: non-parameterized functions, parameterized functions. In parameterized functions also we have two types: call by value, call by reference. So in these all topics we will study one by one the specific function of different type. So now first is functions or member functions. Function is a specific block of code which is used to perform a specific task. This is called function. We can see here the function is a block of code which is used for a specific or particular task, is known as procedure or subroutine in another programming languages. To perform any task, programmer can create functions. Function is a behavior of your product. Function is a behavior of a program. So programmer can create a function for a specific task. A function can be called many times. You will define function one time and you can call function many times. It means you are using code reusability, reusing the same source code number of times. It's called code reusability. So the functions provides modularity and code reusability. Modularity means to divide our program into small units. It is easy to understand and it is easy to implement. If you have any problem in any module, you will be specific to sort out the problem in the particular module. Like is an example, like we are using calculator. In calculator we have different functions, different behavior. Add, we have arithmetic operator add, subtract, multiplication, division. Each and every operator having a different behavior. To add two numbers we need plus operator. To subtract two numbers we need minus operator. So accordingly each operator having a different behavior. If we are running our software and we find a problem with the addition section, so we will check only the module for add. We will not touch the module for multiplication, division or subtraction. It means we are very specific to sort out our issues with the help of modules. So it is very easy to handle the software with the help of modules. One more thing is very important to understand here. We are dividing our software into different modules, so number of programmers can work simultaneously on the same product. If you are not having a modules in your product, only on the one system you can keep all the source code together to implement the software. It is really very difficult to manage the software in this way. It is the best way we can have a team and the team members will work simultaneously to implement a software, it definitely will be performing very high and your time will be very less to manufacture or implementing a software. So we are following these strategies all the time while making a software. Two types of functions. Number one, system defined or library functions. System defined means these functions are already built in with our compiler, built in our system. So these functions we will be keep all the time with our library. Whenever we need to use it, we just call this function. These functions are already defined in the system. We are not allowed to define this kind of functions. These functions are already defined, just we call these functions as per the requirement of the programmer in the program. So system defined functions are the functions which are declared in the C++ header files, such as ceil function, cos function, exponential function, getch to get the character from the keyboard, getS to get the string from the keyboard. So these are the different functions. Example just we have as a system defined. We have many functions. Second is user defined functions. User defined functions are those functions which will be defined by the programmer, called by the programmer. These functions is only implemented as per the requirement of the programmer in the program. So these are the user defined functions. User defined functions are the functions which are created by C++ programmer so that he can use it many times. It reduces complexity of the big program and optimizes the source code. So definitely you are preparing your own functions as per the requirement. You are performing a specific block of code for a particular task. It definitely reduces the complexity of a big program and optimize the source code. Declaration and definition of a function. The syntax of creating function in C++ language is given below. Whenever we are going to implement a function, we should remember three things. Number one, function declaration. Number two, function definition. Number three, function calling. So function declaration and function definition are used to create function, and function calling is used for to get the result from the function. So now function declaration. What is the syntax for function declaration? Number one, return type. Return type may be void, int, float, double, bool, char, string, any type of value. Whatever the function is going to return, it should be the return type of the function. Then function name. Parenthesis. Inside the parenthesis we have a parameter list. In function declaration we use the parameter list if we have a parameters in the function. If we do not have parameter, we will not use here any parameters. This type of function is called default function or non-parameterized function. If we have parameters in our function, is called parameterized function. So here we should remember one point. The point is return type, function name, parameter list. Inside the parameter list for function declaration, it is not compulsory to write the name of the parameters, but you should write the type, data type of the parameter and the number of parameters what you are using inside the function. After that, function definition. For function definition, again we have a return type the same way. Function name, the function name is same in the declaration section and the definition section. Then data type and parameter. Here the name of the parameter is also compulsory to be writing. Data type, here the data type is compulsory. Parameter name you are writing or not, it doesn't mean, but the number of parameters and the type of parameter should be the same in the function declaration section and the definition section. What kind of feature programmer wants to implement inside the function behavior, Accordingly, the programmer will write the source code here. This source code will define the behavior of the function. So here return type, function name, data type and the parameter and these curly brackets. These curly brackets, number 1 for open the function, number 2 close the function. Inside the open and close curly bracket we are writing a source code. This source code is used to be executing whenever we call the function by the name of the function. Next, this is a small example. This is a simple example of C++ function. We see here, first we have written the header file #include iostream, then using namespace std is a root namespace of C++ compiler. Now function definition. Inside the function definition we can see first is return type of the function, then function name, no parameter. We are not passing any parameter to this function. So this type of function is called non-parameterized function or default function. So this is a default function or non-parameterized function. After that we have here inside the function definition static. Static is a keyword. It has a default value 0 for a variable. Here we have using the variable I of integer type. It is a static variable. We are writing a static keyword before initializing the value to the variable I. So this is also called integer type static variable I. Initialize the value 0. This value, if we are not going to initialize, automatically the compiler will give 0 to I. If you are initializing the value other than 0, means 1, 2, 3, 12, 15, 17, 100, anything, this value is fixed and it will retain till the end of the program. So we will understand how it will retain. What is the meaning of retaining the value to the end of the program? First we see the difference between the two variables. One variable is static type we are taking here. Another variable is only integer type non-static. So here we are using the same value to be initialized 0 to I and 0 to j. After that we are incrementing the value by 1 for I, incrementing the value of j by 1. So we know I++ means I assignment operator I plus 1, j assignment operator j plus 1. Then cout I, what is the value of I, it will be print here, and j, what is the value of j, it will be print here, and l for the line feed or next line. Cout is an object to display the output on the screen. This is the whole function definition. We close the function here. Now this is the function definition. Just remember we have one static integer type variable I initialized by 0 and one variable non-static j initialized by 0. Now come to the main body. Inside the main body, main is also a function. Main is also a function. Which type of function? Main is a user defined function. Func is also a user defined function. What is the difference between func and main? The main function is a entry point of the program. Main function always be called by the compiler first. At the first time the main function is always calling by the compiler. This func function is user defined and called by the programmer. The function is calling by the programmer. Where we are calling? We are calling here. Func, we are writing the name of the function, function calling. Again we are writing the name of the function, function calling. Again we are writing the name of the function, function calling. In these function calling we can understand the same function calling by 3 times. The func function we are calling 3 times, 1, 2 and 3. It means we are using code reusability. The code reusability concept is coming to the notice. The func function we defined one time, we designed this function one time, and we are calling 3 times, or you can call 100 times, it doesn't matter. So in this case we can understand the code reusability concept, and the code optimization. We are not writing a same source code again and again. It is also taking a less source code and behavior is more. So this is code reusability and code optimization. Here if we see the output, the first time the value of the variable I and j, whenever we call the function first time, what is the value of the I and j variable? So here I is 0, j is 0, so I increment by 1, j increment by 1, so the value of I and j, I is 1, j is 1. So we can see here the I1 and j1. Now whenever the program starts to execute, always we start from the main. The first time the function, don't we think like that this part of the function will be executing first. No, our compiler will start to execute any program through the main body. First it finds the func function, so it will directly jump to the func definition part and it will display the result in the output section. After that, when this particular part of the program is executed, then the control back again to the main and our program control pass to the next statement. The next statement again we are using a function calling. Func function, when our program control finds, again it will jump to the function definition. Whenever it jumps to the function definition, it will again takes the value I and j. So what is the value of I now? I told you in the start, the static variable always retains the value till the end of the program. So this scope is global and this normal variable, it is not going to retain the value till the end of the program. So its scope is limited. This j scope is only inside the func function, but I scope is outside the func function as well. So the value of I was 1, value of j was 1, but when the function will execute again, that time the value of I is 1 because it retains the value. It is having the value till the end of the program, but j will not retain. It is a normal variable. So again the j will become 1 and I will become 2. So the value of I become 2 and j value become 1. So we will see in the output section the I value become 2 and the j value become 1. It depends on the retention power of the variable. This retention power comes through the static member, static keyword. So now after executing the same func function, the program control back again to the main and program control comes to the next statement. Again the next statement is a func function to be calling, so the jump will become again to the definition part. So here again we can understand here the value of I is 2 here, so this value is become 3 and I value is becoming 3, but the j value again initialized by 0 and it will become 1. So in the section Cout, I is 3 and j is 1. So we can see the output of the program, I is 3, j is 1. So we understand what is the difference between the static and non-static variable in the program. Note, read here, the static variable is initialized only once and exists till the end of a program. It retains its value between multiple function calls. We are using a multiple function call all the time. It retains the value. Its scope is not limited, it's global. The static variable has a default value 0 which is provided by the compiler. If you are not writing 0 here, it will not give any error. It will be initialized by 0 by default by the compiler. Default means automatically by the compiler. Come to the next, advantages of a function. I already told you the function have many advantages, but here I have explained two. Code reusability and code optimization is a familiar advantages. By creating functions in C++ or in any programming languages, programmer can call it many times So programmer does not need to write the same code again and again. So this is code reusability. Code optimization. It makes the code optimized. Programmer does not need to write much code. Programmer is writing the code one time and using number of times. This is also called code optimization, not writing a same source code again and again. Now call by value and call by reference is a parameterized function. So here there are two ways to pass value or data to a function in C++ language, call by value and call by reference. These are the types of parameterized function, because in parameterized function only we are allowed to pass the value. Non-parameterized or default function, we are not going to pass any value as a parameter. So there are two ways to pass value or data to a function in C++ languages. Number one, call by value, call by reference. What is the difference here? We have our original value in the variable. If we use the value to be modified, we will check the value will modify or not. If no, if the original value of the variable is not going to modify, it means we are using call by value. If the value will be modified, if yes, then we are using call by reference. So call by reference can modify the value of the original variable. Call by value just use the copy of the variable. It will not use the actual variable location. There is two different concepts we will understand now one by one. Original value is not modified in call by value, but it is modified in call by reference. We understood this. Now we will discuss one by one. First is call by value. In call by value, original value is not modified. Here, value being passed to the function is locally stored by the function parameter in a stack memory location. It will not change the value of the variable inside the caller method such as main. If we are calling our function inside the main, it will not having a scope till the main. It is having a scope only till the function body is going to be end. So this is call by value. So here we can understand it is only using the copy of the variable, not using the actual location of the variable. We will understand in this program the simple program call by value. Here the first is function declaration. It is a return type of the method, return type of the function, void, name of the function, change, int data, parameter. So here we are using one parameter, integer type, name of the variable, data. Function declaration. Where is the function definition? Here is the function definition. What is function definition? Return type same, void. Name of the function, change, name of the function, change. Type of data, number of parameters, 1, integer type variable data, integer type variable data. After that, inside the function definition change, we are writing a source code, data variable initialized by the value 5. So we have given the value 5 to the data variable. Now it is fixed the value 5. Come to the main body. Inside the main body, we will see we change the value of the variable to 3. So the value of the data variable become 3. Change data means we are calling the function. What is the value we are passing here? 3, because the data variable having a value 3, we pass the value to this data variable, so the value become 3. So we are passing here the change function with the variable value 3. So whenever we are calling this function, it directly jump to the definition part. Where is the definition part? Here. This definition part will directly show the value for this function become 3. So again we are seeing inside the definition we change the value from 3 to 5. So now the value become 5. Now after calling part, after executing this step, it will directly back to the calling part, and after that it comes to the next statement. See out value of data is data and L. what is the value here? The value of this particular member is 3. Even we change the value to 5, but again we are seeing here the value is 3. What is the meaning of this? The meaning is the value is changed. It is not like that the value is not changed. Value is changed, but this value only change inside the change function definition. This value scope is finished whenever the execution of the change function is finished. So after finishing this execution, when our control back to the main body, so this value is not reflecting the change inside the main body. So that's why we are saying the original variable, the original value of this data variable is not changed. Original value is not modified. Even we modify inside the change function, but exactly it is not modified. See out, value of data is, again we receive the value 3 because it is not modified 5. Actually it is virtually modified. It is only modified inside the definition section. When the scope of this execution is finished, the value is originally will be 3 again. So now the value of the data is 3. This is the output of this program. Return 0 to return the value 0 because the main is of return type integer. So that's why it returns the value 0 to the compiler or operating system. Then close the main body, and this is the simple program of call by value where the original value is not modified. Now call by reference. Original value is modified. For call by reference, we should use the concept of pointers. What is the meaning of pointers? The pointers are very helpful for interacting with the memory of the memory location of the variable. So whenever interaction will be done at the memory location, directly the value will be modified at the location of the variable. In the call by value, our variable just use the copy of the variable, not the actual position of the variable. But in call by reference, it use the actual position of the variable. That's why this change is permanent and the value will be modified. In call by reference, original value is modified because we pass reference address. Here address of the value is passed in the function, so actual and formal arguments share the same address space. Value changed inside the function is reflected inside as well as outside the function. So here both the places will show the change. Now we will see the program. Here the return type of the function, name of the function swap, and we pass here two pointer type variables, integer pointer type variable x and integer pointer type variable y. What is the asterisk operator here? The asterisk operator is used to retain the value from the address. So definitely the x variable having a address of another variable, because the pointer definition is to retain the value from the address. The pointer is a variable which retains the value from the address of another variable. So here x definitely is a pointer variable and should retain the value from another variable address. So it will definitely come from other side, the address of the variable. First we understand the concept here. Inside the definition of the swap function, we have one variable of integer type. The name of the variable is swap. So in this variable we are writing a value of pointer x, means this value we pass to the swap variable, and then this pointer variable x is empty now, and we store the value of y to x now. After that the y is empty and we store the value of the swap variable to the variable pointer y. So now it means we interchange the value of x to y and y to x. After that we close the function body. Come to the next part of the program. In this part we see inside the main body we have two variables x and y. X is value initialize 500 and y value initialize 100. You should not be confused with this particular name convention. Here x, here y, here x, here y, but this x and y pointer variable scope inside the swap function, so it will not have any connection with the variable inside the main body. These functions memory allocation is different, these variables memory allocation is different. So don't be confused with this matter. It will interact with the same memory whenever we pass from here, so don't be confused with it. The scope, understand here, the scope of the pointer variable x and y is different inside the swap function, and scope of x and y variable of integer type inside the main function. So here x 500 and y 100 we initialized here, swap. Now you can understand, I told you here the pointer variable always retains the value from the address of another variable. So here the another variable is x. You can take the value in the variable a and b as well. It is not compulsory you write x or y, but here x or y or a or b is same, because the reflection of the main body is different from the reflection of the swap body. So here we pass the address of the x variable and we pass the address of the y variable inside the swap function as a parameters. So we are passing addresses to the function, and these function, whenever we are calling the swap function, these values directly, these address of the value directly comes to the notice by the swap function definition parameter. So whenever your program control comes here, it will directly jump to the swap definition. Whenever it comes to the swap definition, pointer variable x and pointer variable y, here the x having a value from the x variable and y having a value from the y variable. So because the pointer variable gets the value from the address of another variable, so what is the value of this address? 500. What is the value of y address? 100. So these values comes to the notice 500 and 100 here. After that we have understood the concept here. We interchange the value of x to y and y to x. So now the x value become 100 and y value become 500. So these values are interchanged. We are just completing this process, and after that our program control goes back to the main body and we have executed this part of the program. So program control comes to the next. Value of x will be printing here for x, value of y will be printing here for y. We see the output here, the value of x is 100 and value of y is 500. So it means original value is modified, because original value of x is 500 and here is 100. Original value of y is 100 and here is 500. So these values are modified because we interact with the address of the variable. We are passing address to the function, not the value. This is a mistake. To understand the call by reference, programmer must have the basic knowledge of pointers. So read pointers before reading this concept. Now what is the difference between call by value and call by reference? We should see here. Call by value, a copy of value is passed to the function, as I told you. In call by reference, an address of a value is passed to the function. First difference. Second, changes made inside the function not reflecting outside the function. Changes made inside the function and is reflected outside the function also. Actual and formal arguments will be created in different memory locations. Actual and formal arguments will be created in same memory location, because we are using the interaction with the help of pointer and ampersand operator. Ampersand operator holding the address, this is ampersand operator holding the address, this is a pointer variable, it will get the value from the address of the variable. So here, and one more thing, these are the formal arguments and these are the actual arguments. So here we have written actual and formal arguments will be created in the same memory location, but here actual and formal arguments will be created in different memory locations. These are the differences between the call by value and call by reference. Thank you so much. Subscribe my channel, read more and more things from my videos. If you understand, like, comment and share, and show me your response. I will motivate for the next lectures to be making in a very good way. Thank you so much.